also get, I will also get, sorry. All right, I can't remember what I was going to say. Okay, so we're going to talk about a rock. All right, we've actually done part of this problem before. Earlier in the year, we probably did this. So actually, before I even get going, we see that calculator, and when I see that calculator image, I'm going to automatically turn it into, or put it in my, put it in my calculator, whether I'm using calculator or Desmos, but you guys indicated that a lot of you had the graphing. So let's transition into the graphing, and I will try to be really good about using the graphing. On the off chance that we do go take the test in person, you will have to use the graphing calculator. So we need to really get on that this semester and make sure we're good at it, okay? If you're having trouble with it, let me know. And I know there's some bugs. If yours isn't rounding or truncate or using enough decimal points, we're going to have to figure that out. It's something I'm going to have to sit down and do. So let's get that put in. So let's put that in for now. Let's go there first. So let me get into my calculator. And I'm just going to go to my scratch pad. I do a lot of work in my scratch pad. You'll notice that the guest teacher that I've been using for some of our note pages, he does stuff in the docs, and you can do it either way. I typically will have you set up a couple of the docs for the AP test for your free response questions. So that way, if you do a free response question and you move on and you come back, you don't have to retype things in. It's up to you how you want to structure that. If you're for the year, it's your calculator to use, so you can put in the docs whatever you want. I would probably title them though. Okay, like this is example 1 on notes 6 point whatever we're on, or 5, 4, 4, and 4, right? 4 point whatever. Okay, so I'm going to type in that equation, and it was negative 0.8. I'm not going to use the t. Remember, I have to use an x, and then I'm going to hit that little squared button there. And then plus 24x. And be careful. If you do an x in one spot and a t in the other spot because you're copying it, it will throw an error probably at you. And then go ahead and hit enter. Just hit the enter button as soon as you've got that done. And I'm really not worried about where the graph is. I'm probably not going to use the graph. I'm entering it there so I can go back to the calculator page and do calculations. Okay? So let's go read what that first question is that I need to do. So it says we have the height. So when we're talking about position, velocity, acceleration, can you tell me in the chat, what equation do I have? Do I have the position, do I have the velocity, or do I have the acceleration right now? So help me out. Remember, participating today in the chat is going to get you participation points. So I need to see you participating, even if your answer is wrong. We're in no judgment. None of us are judging. Okay. All right. I've got one person who's saying position. What does everybody else think? All right. We are, in fact, good job, everybody who's answered. We are talking about position. That is correct. It's a height. The other clue is it's an S of t. The other thing that we can see is sometimes we'll see X of t. Okay, so that is a position function. Okay, so when it says in part A, I have to find the velocity and the acceleration. How do I find the velocity? Can you tell me that in the chat? Let's review that. How do I find velocity when I have position? What do I have to do? What calculus do I need? Nice job. We've got some people. Okay, good. And remember, by looking at the chat, and the chat not only helps you remember, communicate with me that you're understanding the lesson right now, but it also can help you kind of comprehend the lesson because you can see what your peers are putting in there. Okay. So V of t equals, and we're going to say, I'm also going to use the notation that it's S prime of t. You've got to take that derivative. So I'm just going to go ahead and do that. It doesn't want me to necessarily use the calculator because it wants the, it wants the actual equation. It hasn't told us to put in a time or anything yet. So I remember to do a derivative, I take this and I multiply it by the front. So that's going to be negative 1.6t and then plus 24. All right. Now, to get the acceleration, I have to take the derivative of the derivative, right? So the acceleration at t is the first derivative of velocity and the second derivative of position. Technically, all you really have to write is a of t, but it's a good habit to make that understanding and that connection, so that's why I am writing it that way. So tell me in the chat, what's the derivative of negative 1.6t plus 24? I'm taking a bite of breakfast while you're doing that. All right, excellent job. Sorry, I should talk from my mouthful. My bite of breakfast took longer than I thought it was going to. All right. How long will it take the rock to reach its highest point? Okay. So let's think about the path of that rock. Okay. It is something like this, right? It's an upside down parabola because it's a negative and a squared. All right. Even though we already put it in there, right? We can't really see the picture all the way. I can zoom out probably. Menu, window zoom. I'm just going to zoom out. Oh, you know what I'm going to do? It's better than zoom out. Window, zoom, fit. There we go. Okay, so there's the path of the rock. The highest point has to be up here at the top of that maximum, okay? So in calculus, the way to prove this with calculus, because I could use my calculator to figure out what that is, but we have to prove it with our calculus skills. That top thing there is where the slope is equal to 0. So what I want to do is I want to set my velocity equal to 0 and solve it. So we're going to say that the velocity, v of t, not that. This happens when v of t equals 0. Or when we have this negative 1.6t plus 24 equal to 0, which I guess I really don't need my calculator to do all of it for me. I could probably just do that by hand really quick. So negative 1.6t equals negative 24. Divide by negative 1.6. If I put that, I could put that part in my calculator and I end up with 15. And then remember, we always have to label it. So seconds. You might want to write down and complete it with a sentence that says the velocity. It doesn't hurt to label there. Rock at highest point. Don't use the at symbol on your test, okay? On the actual AP test. Point at t equals 15 seconds. Okay. How high did the rock go? All right, so I need ideas here. I know it's at its highest point at 15 seconds. I need the height at its highest point. So where do I get the height from? Is it from the position, the velocity, or the acceleration? And then what am I going to have to do with that equation? I'm going to give you about a minute. I'm going to be quiet for a minute, take another bite of my breakfast, okay? Now that it's almost lunchtime. And you guys answer that one, so that's going to take you a little longer to type. So everybody think about that. What equation do I need? What am I going to have to do with that equation? Put it in the chat for me. I hope we're just taking a while to type. I don't have any answers yet. I took a whole bite of my food. All right, Jocelyn's saying position, plug 15 into T. Let's see if there's any other opinions on this one. Do we agree with Jocelyn? Is that what you guys think we should do? Position, plug 15 into T. Okay, so Brianna and Jocelyn agree. Okay, so I'm going to go, oh, Sach agrees. Okay, so what I'm going to do is, and remember on the AP test, we have to be very careful about our notation, and that's really important that we have proper notation, okay? So we're going to say position, and we're going to tell the grader what we're plugging in. So I'm plugging in 15. Now, because this is a calculator problem, you probably don't need to show the step where you actually plug the 15 into here. You can just write the answer. So I'm going to go to my back to my calculator. I'm going to go to the home or the calculator page. My position equation is sitting in F1. So I'm going to use var. I'm going to pick F1. And then I'm going to just type that number in, 15. I think those of you, at least, that had me for trig last year, I believe we did at least that much before this whole thing started, right? I think we learned how to use var last year, I think. I don't know what Sagita did in pre-calc last year, but I know we learned at least that much. All right, so we got 180. Okay, what label should I put on 180? Can you guys tell me in the chat? We're talking about height. Look at what I've got back. Look back in the question stem. What label do I need to put on the 180? All right, and remember, though, you need to help me by participating in the chat, okay? Because that's how I'm counting participation today. So we are definitely doing meters. Okay, and M is an acceptable abbreviation, okay? If you wanted to put it in a sentence, you could say the rock went 180 meters, okay? Or the highest point of the rock was 180 meters. We could even do that. The highest point of the rock was 180 meters. Okay. Now it says, how long did it take the rock to reach half of its maximum height? Okay. So what if its maximum height was 180 meters? What was half of the maximum height? Can you tell me that in the chat? So what's half of the maximum height? All right, more participation on that one, okay? Half of the, thank you for correcting yourself, Kyle. All right, half of the maximum height has to be 90, right? So if I'm looking for how long, I'm going to set the height equation equal to 90. And I'm going to show you a trick on the calculator on how to solve this, because look at what loveliness this is. It's like a mess now, right? All right. So I could move, if I was going to think about solving quadratics, I could move that 90 to the other side, set it equal to 0, and then use the good old quadratic formula. But why would I risk making a mistake with a whole bunch of decimal points on the quadratic formula when I've got my calculator to help me out right now, okay? This is basically a systems of equations. This we know is the position function we put in. I'm going to put that 90 in my calculator, and we'll use it to, we're going to kind of use the calculator to do the work for us. So I'm coming back over here to my calculator page. I might adjust my window here in a minute, but I'm going to hit the tab key and I'm going to type in the 90, and I might does a little weird thing there. So I'm going to type in the 90 and then hit enter. So tab on F2, type in 90. Tab on F2, type in 90 and hit enter. And notice it crossed. Oh, that is not what I wanted to do. Mrs. Ballard, let's see if I can get Control Z to undo it. Okay. So the nice part about your Inspire calculator is it works very similar to a computer. So notice how I got my equation back. I hit Control Z, which is undo. Okay. So I shouldn't be touching that. I was trying to get my little label out of the way because it annoys me, but I should have used my mouse to do it instead of my finger. So there we go. All right. If that's a good zoom for you, you leave it. I'm going to adjust it a little bit so I make sure I'm accurate on those things. I don't know. That's just my personal preference. Window, that is not the button I wanted. Window settings. I don't need much of my negative Y. My X looks really good, but I don't need much. I don't need 1600 there. Okay. So I'm going to switch it to like, I don't know, -5. All right. I'm going to leave my 300 on my Y max. Let's see what that does to it. That's a little bit better. Okay. I can very clearly see where those intersection points are now. So now I'm going to go to menu. And if we want to make a calculation on the graph, that's where we go to analyze graph. And we're going to go to intersection. So menu, analyze graph, intersection. And then it says lower bound. I'm going to drag my line to the left of the lower bound, though it doesn't really matter. I'm going to click. Okay, and then it says upper bound, question mark. And I'm going to keep dragging until I see my intersection point pop up. And again, I'm somehow, for some reason, getting only 2 decimal places, and I have yet to look up what's wrong with this error. We might need to do an update or something goofy. If you're only getting 2 decimal places and you've reset your float to 6 or 8, we need to figure that out. I know that one of my BC kids was having trouble with that. So if you got a whole bunch of decimal places, that's what we want. We want it beyond 3. I'm gonna do it again. Menu. Analyze graph, intersection. I'm going to go to the left, go to the right. My other one is at 25.6. Okay. So how long? Okay. If you were being asked this question, okay, how long did it take the rock to reach half of its maximum height? The answer that makes more sense is half the first time, not half the second time, right? It's a quadratic, so we know it's going to have 2 answers, right? But it would reach half of its height in about 4 seconds, right? Versus we wouldn't wait for it to come back down at 25 seconds. So half the height would be the first number that we see. So let's write that out, okay? So the rock reaches half. Actually, we should probably write down what T is. So T equals, really we should have had that decimal point or 25.567, okay? And it doesn't hurt to put seconds on those. All right, the rock reaches half its max height at T equals 4.433 seconds. And again, my extra values on my decimal point, I cheated and I used the answer key because my calculator did not, for some reason, pop them up. All right, hopefully we're doing okay. You guys got to let me know if you're not. All right. So I'm going to ask for some ideas on E. So start thinking about E as I start talking through it. Okay, get your answer starting typed in the chat. Don't hit the enter until I ask the question completely. Okay. So how long was the rock aloft? Meaning, how long was that rock in the air? Okay. What are some ideas of how we would figure out how long it's in the air? Think about what the height would be when it's not in the air anymore. Okay, so I'm going to give you about a minute of think time. Okay, so think about that for maybe 30 seconds of think time. You can start typing it in the chat if you know it. Okay, then we're going to type it in the chat. Okay, so what are our ideas? how do we figure out how long the rock was in the air? Or at least, what would the height be when it's no longer in the air? Can you tell me that in the chat now? The rock's height has to be 0. So if the rock's height has to be 0, that means I need to take the position function and I need to set it equal to 0. So I'm going to take that position function that I had. And it might not be a bad idea to say the rock hits ground when S of t equals 0. It's always good to tell the reader your thoughts, okay, so they know what you're talking about. And sometimes they award points in weird places, okay? So S of t equals negative 0.8 t squared plus 24 equals 0. Now, we could, there's a lot of ways we could do this. It is a calculator problem, so I'm going to show you how to do this with a calculator, because they probably wouldn't be looking for the 2 calculations in between. We could factor out and do a greatest common factor and zero product property and all of that. But let's use the power of our calculator. I sort of left my x-axis in there. Let's go back and adjust that again. Window zoom, window settings. I'm going to make this like 100 now. So let's see, negative 100. All right, so what I want is I want to calculate the 2 zeros. So I'm going to go to menu, analyze graph, 0. So that was menu, analyze graph, 0. I have to pick the graph, so I'm going to pick my blue graph. And then it says lower bound. So I'm just going to go to the left, go to the right. Notice my 0 popped up. So the first place the rock is on the ground is at 0, 0. That makes sense, right? No worries, Kyle. It happens to everybody. My daughter has the same internet I do, and she drops off and on all day, and I'm on just fine most of the day. So, and my son's the same thing. His is on all fine all the day, but I know that you guys' Chromebooks, they drop off and on. So I appreciate the feedback, though. All right. So I really want that second spot. That's the spot I want to know about where it's at the ground, right? But I would write down the 0 as part of my answer, and then I conclude it with the actual timing there. Okay, so I'm going to do that again. Menu, analyze graph, and 0. And then I'm going to pick the graph. Sometimes, if you only have one graph in there, you don't have to do that step. And then go to the left, go to the right. So it looks like it hits the ground at 30 seconds. Okay. So t equals 0, comma 30. And then let's see where the whatchamacallit, let's write a concluding sentence. So the rock, and again, always go back to the nouns that are in there. The rock is aloft for 30 seconds. Make sure you always, always, always label whether it asks for it or not. And if you notice, just a notice, we wanted to know the highest point, right, up here, and how long. Notice it was 15, and notice that the total aloft was 30. So interestingly enough, at halfway, it only took double the time to get back down. Okay, I know this is something and asked that it was in there either in the last couple days or it was in there before break probably. We talked about their speed. So remember that speed is the absolute value of velocity. So when I need to find speed, I take the absolute value of velocity. So the rock's speed when hitting the surface of the moon. Well, we know it hits the surface of the moon at 30 seconds. So that means I need to take the absolute value of velocity at 30 seconds. Again, I'm going to use the power of my calculator. I could plug this in and crank it out by hand, but I'm going to use the power of my calculator to help me with that one. I'm going to go back to the scratch pad or to the calculator page of the scratch pad. And I'm going to hit the button next to the book. I want to say it's called like the math something button. I don't remember its official name, but I'm going to hit that button next to the book. And you'll notice that my absolute value bars pop up. They're right there. Okay, so button next to the book, absolute value bars. And again, I know that thing has a name. All right, so that popped up, and then I'm going to go to var. I know my function is my, oh, wait, we want the derivative of that function, right? Oh, I'm not going to go to var yet. So to get derivative, there's a couple of ways to do it. You can go menu. Actually, we do need to go menu because we need to plug in a specific number, right? So menu, calculus, because what's in var is our position, and we need the velocity here, okay? So I'm going to go numerical derivative at a point. And then the value we want to calculate is 30. I'll go through the steps one more time and click OK. Okay. So to get that there, what I did was I went to menu, calculus, numerical derivative at a point, and I typed in the value of 30. And I clicked OK. And I left it as first derivative versus second derivative. I'm going to hit cancel because I already have that. And now I hit var. Var, our function that we're taking the derivative of is f of x. Plug in an x and then hit enter. Do we all get 24? Okay, so I'm going to write that down, 24. Now help me out. What should my label be? We are talking about velocity. So we took a derivative. What should my label on this be? Remember, derivative is a slope. So it shouldn't just be like meters. What do you guys think? Tell me in the chat. It'll probably be our last question in the chat. Excellent. Meters per second. And remember, the time is always going to be on the bottom. Okay? Your distance is going to be on the top. Your time is always going to be on the bottom. So this is happening at 24 meters per second. All right. So the good news is that that's it for that lesson. Okay. But I'm not going to try to move on to another lesson today. Okay. I'm going to give you the rest of the time to keep working on your homework. Can you guys tell me in the chat, when is the homework that I've assigned up to this point due to be on time and get extra points? So when is it due? Oh, Friday. Charlotte's got it. Friday at 5, right? Has to be in by 5 o'clock at 5:01. It's late. I will still take it, but there's no extra credit points, right? So you want to get it in before Friday at 5. We are looking, so I didn't put anything new. I don't think there's anything else in Google Classroom. I will try to get this video up here in the next few hours in case you missed anything. I will also post the notes packet as well. I know the notes 4.2 were already there, so I didn't put it up yet, but I will get up Get up to school before tomorrow if you can. I think they're there till 3:30 today. Get up there, get the new notes packet. They're sitting there ready for you, hot off the presses. And get that so you can have something to write on, because I know that's kind of where our comfort zone is. Okay. In here, I just basically said finish the 2 assignments and get the notes turned in. Okay, so those are the only 3 things I'm expecting to see before Friday. Okay, do we have any questions, comments, or concerns while I set up the joke of the day? Are you all ready for an English accent? I think it's an English accent. I'm not sure what kind of an accent he did. But he had an English accent. He had some kind of accent today. All right. Here we go. He uses an emoji on his head the whole time. I don't know why. I think just because he likes emojis.
Hey guys, it's me, Andy. Now I'm going to tell you a really funny math joke, okay? Or it really is Andy, really. So, what's the joke today? Oh yes, right. I forgot. Just kidding. So, what happens when you have nerds? If your family's all nerds? Then you have square roots. Thank you for joining me.
Well,
now, goodbye.
We have all kinds of square roots in this house, so all right. That's it for today. So what you need to do, if your first period teacher did 45 minutes, you need to get up and move around. Even if they didn't do 45 minutes, you need to get up and move around, okay? Because today is going to be a really long day. We need to get in that habit of getting up and stepping away for a few minutes. I'm going to do the same thing because I've been going since like 7:45 on this thing. I've gotten up for maybe 5 minutes. So I'm going to get up and move away. Make sure you get those assignments and then spend some time later today on them. You don't have to do them right now. Go get up and move around. That's the healthy thing to do right now. Okay. So I will hang around for a minute or two here if you've got questions. If not, I will see you tomorrow. Okay. So have a great day. Bye, Brianna.